Okay, so yesterday we reviewed the 5 kinds of chemical reactions. The 5 kinds of chemical reactions are synthesis, where 2 elements combine to form a single compound. Simple decomposition, where a single compound breaks down into its 2 elements, so those 2 are the opposites of each other. Okay? Combustion reactions, where a molecular compound containing carbon and hydrogen reacts with oxygen, producing carbon dioxide and water. Single replacement reactions, where an element reacts with an ionic compound and switches places with whatever part of the compound it's like. And double replacement reactions, where 2 ionic compounds react and switch partners to create 2 new ionic compounds. Right? Those are the 5 reaction types that we went over. Right? We also talked about balancing of chemical reactions. Okay? For everything except a combustion reaction, we generally pick the biggest number, and we go back and forth until we have the reaction balanced. Combustion reactions obviously have their own balancing rules, alphabetical order, and the rule of 2. Okay? And we also worked a little bit on writing the reactions out in words. Okay? So we're going to do a little bit more of the writing the reactions out in words, identifying and balancing, but we're also going to move towards the way that you're more likely to see this done, and that is you're going to get the reaction written in words, and you're going to have to write it out in formula form. Okay? Balance it, identify the type, all of that kind of stuff. So that's kind of where we're headed today. Okay? So just as a quick review from yesterday, let's do number 1 together here. Right, so I've got in number 1 a single reactant, okay, and it's breaking down into its 2 elements. So what kind of reaction am I looking at there? That's a decomposition reaction, okay? The only reaction type we have that has only 1 reactant is decomposition. All right, then we need to write it out in words. What kind of compound is this? Ionic or molecular? It's molecular, it's 2 nonmetals, so I got to name it as such. Means I need prefixes. Trinitrogen dioxide. Okay, and that's going to break down into these 2 elements. Do the fact that they have 2's change their names at all? No, these are the special polyatomic or molecular elements. Okay, so this is simply nitrogen and oxygen. Okay, what should I start balancing first? The nitrogen. Yeah, it's the biggest number. Okay, I've got 3 nitrogens on the reactant side. I only have 2 over here. Okay, what can both of these multiply into? 6. The lowest common multiple is 6 for those 2. Okay, so I'm going to multiply this one by 2. That'll give me 6 nitrogens there. When I do that, it's going to give me 4 oxygens. So I'm going to go over here, make sure I've got my 6 nitrogens and 4 oxygens. My reaction is balanced. Okay, guys, I know maybe at first this looks kind of intimidating. It can be, but it also just takes practice. They're all basically the same. Okay, you follow the same set of steps, and once you get those steps down, okay, it doesn't matter what reaction you're looking at or how complex it looks, you can still balance it, still write it out, okay, all of that kind of stuff. All right, so I'm going to give you guys a little bit of time here to do 2, 3, 4, and 5, okay, and then we'll go over those together. Okay, so you're identifying the type, balancing, writing it out in words, okay, for each one. Okay, so on our second reaction, we have calcium, which is an element. In particular, it's a metal. Okay, reacting with iron 3 chloride, which is an ionic compound, metal and non-metal. Right, so what kind of reaction am I looking at here that starts with element and ionic compound? Single replacement. Okay, so that's my first thing. This is single replacement reaction. Now I need to write it out in words. Okay, so this is calcium, right? This stuff is iron with chloride, but what do I need to put in this? A Roman numeral. Iron has more than 1 possible charge. Okay, well, I need to figure out which one it is. Chlorine's always a -1, so there are 3 negatives. There's only 1 iron, so it must be the iron with the +3 charge, so Roman numeral 3 beside that. That is going to make iron by itself, and this ionic compound, which is calcium chloride. That one doesn't need a Roman numeral because calcium does not have more than one possible charge. Okay, so that's what our reaction should look like written out in words. And now I need to balance this thing. So I'm going to start with chlorine because it's the biggest number. On this side there are 3, on that side there are 2. What's the lowest common multiple? 6. Okay, so I've got to make sure I've got 6 on this side. Now I do. What needs to go here? 3. Okay, so now I've got the chlorine balanced. But when I put a 2 here, it also gave me 2 iron atoms. So I've got to go over here and put a 2 in front of that to make sure my iron's balanced. Okay, when I put this 3 here, that gave me 6 chlorines, but it also gave me 3 calciums. So I've got to go back over here and make sure I've got 3 calcium atoms. If you were to get a reaction like this on a test, okay, you would get 3, maybe 4 marks for a question like this, okay, depending on how I've decided to do it. Okay, you would get, in some cases, a mark for writing out the reactants and a mark for writing out the products. Okay, so if you forgot the Roman numeral 3 here, you'd lose your mark for the reactants because you didn't have the right names. Okay, you would get a mark for the reaction type, and you would get a mark for having the equation balanced correctly. So you'd be looking at 3 or 4 marks. Okay, it's 3 if I just am giving 1 mark for the whole written reaction. If you make 1 mistake, you just lose it. Sometimes I give 1 for the reactants and 1 for the products. It just depends on the question. All right, how many people have done number 3? Are we having a hard time with 3? Okay. Okay, let's maybe have a look at it first. So I've got carbon and hydrogen together reacting with oxygen. What kind of reaction is that? It's a combustion reaction. Okay, that's important for us to know because it's going to dictate how we do the balancing. Now, how do I name this? I didn't give you the prefix for 14. I don't know what the prefix for 14 is. So that one's unfair. This stuff is actually called hexane. There's a big naming convention you use for naming organic compounds like this that you'll learn in Chem 20. It's like the second thing you do, okay, is naming organic compounds. On a test, obviously, I would not give you one that has too big a number for you to do the prefixes of. If I did, I would give you the name. Okay. All right, so this stuff is hexane. It's reacting with oxygen gas. Okay, that is going to form carbon dioxide and water. Okay. So there's 2 balancing rules for combustion reactions. The first rule, balance it in alphabetical order. The second rule is the rule of 2. Okay. Do I need both rules for this one? I do. Why? Right, 6 is an even number. Okay, anytime there's an even number of carbons, I start my balancing with a 2. All right, so now I can start my balancing in alphabetical order. What's 2 times 6? 12. All right, so I go over here. My carbons are balanced. There's 12 of them. Okay, what's 2 times 14? 28. All right. What times 2 will give me 28? This is the fun part, is that you don't actually have to think about it. Okay, it's the same number. All right, on that side. Now, I have to do my oxygens. Now I got to do a little bit of math. It's not terrible. I got to multiply some numbers and add them together. Okay, so I've got 14 oxygens here in the water, and another 24 oxygens here in the carbon dioxide. Okay, for a total of 38 oxygen atoms. Right? What's 38 divided by 2? 19. Now my reaction is balanced. That's about as tricky as they get because the numbers are kind of big. Okay. Most of the time I try and keep the hydrogens under 10. All right, give you a few more minutes here to try 4 and 5, and then we'll have a look at doing number 6 together, because obviously that's the one I was telling you about, where you're going to get it in words and you're going to have to write it out in formula form. Okay, so I'll give you a few more minutes on 4 and 5, and we'll walk through those. If you're having trouble, let me know and I'll come help you. All right, so for number 4, okay, we're starting off with 2 elements, and they are combining to form a single compound. All right, so what reaction type are we looking at there? Synthesis reaction, yeah. Okay, and identifying the types, guys, I mean, you do have to memorize the reaction types. There's no getting around that. After that, it's just recognizing the pattern. Okay. All right, so we got to write it out in words. This stuff is chlorine. This stuff is lithium. Oh, but not with a capital L. Okay, and that's going to give us lithium chloride. Okay, now, and I just wrote it as LiCl, which is dumb because I'm supposed to write the name. Lithium chloride. Okay, ionic compound, so no prefixes, no Roman numerals are necessary for that. All right, so why did I write lithium chloride LiCl when lithium was listed second in the reactants? Why didn't I write it in the order the reactants are? Exactly, yeah. The ionic rules say the metal always gets listed first in the compound. I don't have to list it first in the reaction. It doesn't matter what order it is here. Okay? But when I put them together in a compound, it's metal first, non-metal second. Okay? Everybody follow me there? I will do that when we get to the part where we're predicting the products of a reaction. I'll do that exact same thing. What you'll have is just that, and I'll ask you to predict the products, and you will be shocked at how many people will go CLLI, because they'll forget. Okay? Don't forget that simple little rule that when you write a compound, the metal's first, the non-metal is second. Okay? So just keep that in mind. I don't have a lot of tricks in the bag. That's one of them. Okay? And I'm telling you right now, I will do that to you at some point. So be ready. All right, how many people have done number 5? Okay, do we just need a little more time, or are we stuck? More time? Okay, give me another minute here, and then I'll go to number 5. So for number 5, okay, I've got an ionic compound, okay, reacting with another ionic compound. We have metal, non-metal, metal, non-metal, okay, and that's producing 2 different ionic compounds. What's my only reaction type that's got all ionic compounds in it? Double replacement. Yeah. Okay, so this is a double replacement reaction. All right, now I need to write it out in words. This stuff is magnesium fluoride. It's reacting with cobalt with nitrate, but cobalt has more than one possible charge, so this one needs a Roman numeral in its name. Okay, nitrate's always a -1. There are 3 nitrates, so there are 3 negative charges. Okay, that means I need 3 positive charges out of the cobalt, and there's only 1 cobalt, so its charge is 3. This is cobalt 3 nitrate. Right, and that's going to form magnesium nitrate and cobalt 3 fluoride. Here's some good news for you, because I don't know how many people maybe did this. How many people figured out the charge a second time? Okay, you don't need to do that. It won't change. Okay, if I start out with cobalt 3, I end with cobalt 3. It's Dalton's atomic theory, right? You can't change what you have. Okay, you can't change one element into another element. I know it's still cobalt, but I can't change, if I have cobalt 3 plus, I can't change it to cobalt 2 plus with a chemical reaction. Okay, it'll stay cobalt 3 plus. Same for any of the others, so you never have to figure out the Roman numeral twice. It'll be the same on both sides of the reaction. Okay. All right, questions on the first 5 there? Okay, so let's look at the other way that these can go, and that is I give you the reaction in words, and now you need to write it out in formula form, identify the type, and balance. So you're still identifying type and balancing, it's just you can't do that until you've written it out in formula form, which means you got to be good at converting chemical names into chemical formulas. Okay, the other issue with this being tougher is if you get any of the formulas wrong, will you be able to balance the reaction? Well, you might, but it'd be wrong. Okay, so you got to get the formulas right, or you won't be able to balance the reaction. So, as a tip for you, if you've written out all the formulas and you're trying to balance a reaction and you can't make it work, probably one of the formulas is wrong and you should go back and check it. All right, so we're going to start out with copper 2 nitrate. All right, so copper is Cu, and the Roman numeral tells me that it's the copper with the 2+ charge, and it is bonded to nitrate, which has a -1 charge. So now I drop and swap. When I need to put a 2 beside a polyatomic ion, I have to put it in brackets. All right, so there's my first compound, copper 2 nitrate. It reacts with magnesium. Okay, magnesium's not with anything, so it's just magnesium as an element. Okay, and that's going to form magnesium nitrate. Magnesium's a 2+, okay, nitrate is a 1-, so we drop and swap. Okay, and calcium, or sorry, copper, sorry, not calcium. All right, so now I've written out the reaction in formula form. What kind of reaction is it? It's a single replacement reaction because I've got an ionic compound reacting with an element, forming a different ionic compound and a different element. Okay, so a single replacement. Okay, now I need to balance this thing. Done. How do I know I'm done? Oh. How many copper are there here? 1. How many copper over there? 1. How many nitrates are here? 2. Here? 2. 1 magnesium. 1 magnesium. It's already balanced. Okay, everything's already worked out. That happens sometimes. Don't overthink it. Okay, if you think it's already balanced, it might be. Okay? Don't start adding numbers just because you feel like I would never do that. All right. Number 7 is going to have some big balancing numbers because of these two things here. Okay, I didn't give you the name of this so that you could just start it out. Whoops. Like so, okay? What's it reacting with? Oxygen. Now, here's the thing I want to illustrate with this. When oxygen is an element, what does it look like? O2. This is where that's important, okay? Those color-coded elements on your periodic table. You've got to be on the lookout for those when you're given the reaction in word form, because it doesn't tell you that, okay? I have to remember that oxygen is one of my color-coded elements, and it comes as a 2 when I write it out in formula form, because if I don't, I might still predict the products correctly, but I won't balance the equation correctly. All right, and what does that always form? Carbon dioxide and water. What kind of reaction is that? It's a combustion reaction. Okay, let me give you a minute to see if you can balance that one. Remember your 2 balancing rules for combustion reactions. No. No, because it was already balanced. I didn't remember it. You're late. I just skipped right over it, didn't I? It's just because I'm old and forgetful. But yes, you should balance that reaction. And it would look like that. Yep. Okay, let's look at our balancing for this one. All right, so balancing on this one, we've got an even number of carbons. So what do I need to start with? 2. So I'm going to have really big numbers. I was going to have big numbers if I didn't have a 2 here. Now I'm going to have twice as big a numbers. Okay, 2 times 12 is 24. So I've got to go over here, balancing in alphabetical order, and make sure that I've got 24 carbons. Okay, then I've got to look at my hydrogens. Okay, I've got 52 hydrogens on this side. Okay, so I'm going to go over here and make sure I have 52 hydrogens. 26 times 2. Now I can balance my oxygens. All right, so over here, I've got 24 times 2 is 48. Okay, plus another 26 is 74, right? Yeah, I think so, 74. Okay, so I gotta go back over here and make sure I have 74 oxygens. 37 times 2, 74, yeah. So I shouldn't do math in my head. I should have just pulled out the calculator when I got lazy. Okay, everybody all right with that one? Okay. I wouldn't give you one that had that kind of big numbers on it on the test or quiz. And like I said, I'll try and keep it under 10 hydrogens most of the time. All right, I want you guys to try 8, 9, and 10. I'll give you a few minutes to try those and then we'll walk through them together. So same idea here, you're writing it out in formula form, okay? You're identifying the type and balancing. Okay, remember on ionic compounds, do your drops and swaps, okay? And remember what, probably there's no Roman numerals, so you don't have to worry about those. Okay, so super important to remember those color-coded special elements because you have one of them here. Okay, so this is going to break down into lithium. That's obviously not our special color-coded one, but the other one is. Nitrogen, when it's in its element form or by itself, comes as a 2. If I forget that, then I'll lose the mark for the reaction and I'll lose the mark for the balancing because I won't be able to balance it correctly either. I might be able to get the reaction to balance, but it won't be the correct balance. Okay? So now that I've got that, now I've got to look at balancing the whole reaction. Now, we always say start with the biggest number, and we say that because 98% of the time it works. This is one of the cases where it doesn't. Okay? If I just balance the 3 first, I'm going to have to erase that because I won't be able to make the nitrogens work. I have to put a number in front of this to make the nitrogens work first. Okay? So every once in a while you run into a reaction where going with the biggest number first doesn't work out. Okay? And that's fine. It happens once in a while. All right, so I'm going to start with a 2 here because that will make sure that I have 2 nitrogens on that side and 2 nitrogens on this side. And that now gives me how many lithium? 6. All right, what kind of reaction am I looking at? Which kind? Decomposition. I have a single element breaking down, or sorry, a single compound breaking down into its elements. So that one is Right, some people have done number 9. Okay, you just need a little bit more time? Okay, give it a few more minutes, then we'll look at number 9. So I've got hydrogen sulfide. You can also spell that not with a pH, but with an F. Doesn't make any difference. Okay, so I'm going to have hydrogen, which is a +1, with sulfur, which is a -2. So I've got to drop and swap because it's an ionic compound. Hydrogen's listed first, acting as a metal. Okay, so H2S. Okay, that's that dangerous stuff that's associated with drilling for oil and gas. Okay, if you're working on rigs or anything like that, you usually have to take your H2S certification because you inhale this stuff and it will literally dissolve your lungs. It's really, really bad for you, but there can be pockets of it associated with natural gas and oil. Okay, when a drilling unit punctures one of those bubbles, that gas comes up and it can be very dangerous for the people working on the rig. Okay, so they have to be trained in how to deal with it. All right, it's going to react with calcium hydroxide. All right, so calcium is a metal, so this is an ionic compound. It's got a 2+ charge. It's with hydroxide, which is a polyatomic ion acting as a nonmetal with a -1 charge. So when I drop and swap, okay, CaOH2. All right, what kind of reaction am I looking at if I've got 2 ionic compounds reacting with each other? Okay. Double replacement, right? So we can write that right now before we even write the products. We know it's double replacement. Okay, and so that's going to make calcium sulfide and water. Okay, so calcium's a 2+, sulfide's a -2, so that compound's already swapped and dropped, CAS, and water is obviously, why am I writing it like that? Could I write it as H2O? Yes, I could. Here's why I'm writing it that way. It's going to be easier for me to balance this reaction writing water as HOH because the two things that made it up are here, OH, and here, H. It'll be a lot easier for me to track where all the parts of it come from if I write it the way the pieces were put together as opposed to as H2O. Right? So in a replacement reaction, if water is one of your products, write it as an ionic compound, HOH rather than H2O. Okay? It'll just be easier to track where the parts come from. In a combustion reaction, write it as H2O. It's way easier to track where the parts come from because they were H and O rather than H and OH. Everyone kind of follow? All right, so biggest number, hydrogen and hydroxide. They're both 2. So I'll start with hydrogen. It won't matter which one I start with. Okay, there's 2 hydrogens over here. Okay, I need to put a 2 in front of this to make these 2 hydrogens work. That will also give me 2 hydroxides, and there are 2 hydroxides over here. So now that one's balanced. That's what I meant by easier to track where everything came from. Okay, now that that's done, I can look at my sulfur. 1 sulfur over here, 1 sulfur on the reactant side, one calcium on the reactant side, 1 calcium on the product side. That reaction is now balanced. Okay, only had to add 1 number. All right, we'll give you a couple more minutes to try number 10, and then we'll go over that one together as well. So remember, special elements, super important. Phosphorus comes as a 4 by itself, oxygen is a 2 by itself. We got P3O2, triphosphorus dioxide. What kind of reaction are we looking at if we got element plus element equals compound? Synthesis. Okay, now I need to balance this thing. What should I start with? Yeah, start with the 4. Start with phosphorus, biggest number, it'll work this time. Okay, I got 4 on this side, I got 3 on that side. What's the lowest common multiple? 12, yeah. Okay, so I'm going to put a 3 here. 3 times 4 is 12. What needs to go in front of this? 4. Yeah. Okay, now I've got my 12 phosphorus, but putting a 4 here also gives me how many oxygen? 8. I got 8 over there. Okay. Is it always kind of the same set of steps when we're going through this? And that's the thing. We just need to practice it. Once we get the steps down, okay, there's nothing too difficult about this. Now, if you're struggling with the writing the compounds and writing the names, that's a skill you got to practice as well. Okay, we kind of in Science 10 take for granted that you've already done that. Okay, you already know how to balance or how to write a chemical name or write a chemical formula. We spent a couple of days on it at the beginning of the semester here, okay, but we don't spend any more time than that on it. That's one of those prerequisite skills we expect you to come with. So if that is something that's giving you trouble, then let me know. Come in and see me for help, and we can get it sorted out. It's not hard. Okay, you just got to get it sorted out so you know how to do it, because you won't be able to do this stuff if you can't do that. Okay, it's like you can't play basketball unless you know how to dribble the ball. Okay, it's just one of those prerequisite skills you got to have. Okay. All right, in your digital workbook, which I'll call up here, okay, are some practice questions that I want you to work on. Yeah, it's me. Okay, so if you go on the class work tab here, same place as before. Okay, it's going to be in your worksheet booklets there. And you want the chemistry one. Okay, so you got all those naming ones there. Okay, so this is where we're going to start. Page 8. Okay, is where you need to go to, okay, and we got some reactions there, very much like what we were working on before. I'm giving them to you in formula form. I want you to identify the type, write it out in words, and balance. If you want to do that right in the Google Doc, okay, you're obviously welcome to do that, right? That's entirely up to you. Sometimes stuff like this is better done on paper, but whatever's more comfortable for you guys, I'm fine with. Okay, make it a little bit bigger here so we can see the whole thing. All right, so those are the reactions we're working on, and I just posted in Google Classroom just a couple of minutes ago, okay, the key for all of these worksheets. Okay, so if we go back to the stream here, right? Keys for reactions worksheets. There's a PDF there. Okay, you can check your work as you go. Now, here's my suggestion with using those keys. Do about 3 questions, but don't do more than 3 before you check the key. In fact, if you want to check the key after every question, be my guest. That's what it's there for. But what I don't want is for you to do like 10 and then check the key, find out you've done all 10 wrong and all you've done is practice bad habits for 10 questions. Okay? Make sure that you're checking on each one or every 2 or 3 at the most. Okay? And then if you're having trouble, let me know so I can come and help you. Okay? Identifying the reaction type, writing it out in words, and balancing it for this sheet for today. Okay? All right. Have at it there, guys.